Welcome to module 2. So in this module we will discuss on the basic configuration of switch and devices. You will gain a basic understanding of the way network operations and here is the objectives for this module. So our first objective is Cisco IOS Access. So all end devices and network devices require an operating system. As shown in this figure, the portion of the OS operating system that interact directly with computer hardware is known as the kernel. The portion that interface with applications and the user is known as the shell, and the user can interact with the shell using a command line interface CLI or a graphical user interface as known as GUI, right? So basically when using a CLI, the user interacts directly with the system in a text-based environment by entering commands on the keyboard at a command prompt, right? So as shown in this example, the system executes the command uh, providing a textual output. The CLI requires very little overhead to operate. However, it does require that the user have knowledge of the command and a command structure that control the system, right? So first is GUI. A GUI such as in Windows, Mac OS, Linux, Apple iOS and Android allows the user to interact with the system using an environment of graphical icons like menus and windows, right? So the GUI example is in the figure is more user friendly and requires less knowledge of the underlying command structure that control the system. For this reason, most users rely on GUI environment, right? However, GUI may not always be able to provide all the features available with the CLI, and GUIs can also fail, crash, or simply not operate as specified. For these reasons, network devices are typically accessed through a CLI, right? So the CLI is less resource intensive and very stable when compared to a GUI. The family of network operating system used on many Cisco devices is called the Cisco Internet Work Operating System (IOS), and Cisco IOS is used on many Cisco routers and switches, regardless of the type of size of the device. And each device, router or switch type uses a different version of Cisco iOS, and other Cisco operating system include iOS, iOS XR, iOS XE, NX iOS, right? Now, purpose of an OS. Basically, network operating system are similar to a PC operating system through a GUI. A PC operating system enables a user to do the following, like use a mouse to make selections and run programs, and enter text and text-based commands, and view output on a monitor. But a CLI based network operating system, for example, Cisco IOS on a switch or router, basically it enables a network technician to do the following, like use a keyboard to run CLI based network programs, use a keyboard to enter text and text based commands, and view output on a monitor, right? So Cisco networking devices run particular versions of the Cisco iOS. The iOS version is dependent on the type of device being used and the required features. While all devices come with a default iOS and feature set, it is possible to upgrade the iOS version or feature set to obtain additional capabilities, right? So a list of iOS software release for a Cisco. switches. Now, access methods. Basically, a switch will forward traffic by default and does not need to be explicit the configured to operate. For example, two configured hosts connected to the same new switch would be able to communicate, right? Regardless of the default behavior of a new switch, all switches should be configured and secured. And some devices, such as router, may also support a legacy port that was used to establish a CLI season remotely over like telephone connection using a modem, right? So similar to a console connection, the AUX port is out of band and does not require networking service to be configured or available. Now, terminal emulation programs. There are several terminal emulation programs you can use to connect to a networking device either by serial connection over a console port or by an SSH or telnet connection, right? These programs allow you to enhance your productivity by adjusting window size, changing font sizes, and changing color schemes. So our second objective is iOS navigation. In the previous topic, you learned that all network devices require an OS and that they can be configured using the CLI or GUI. Using the CLI may provide the network administrator with more control and flexibility than using the GUI, right? So this topic discuss using CLI to navigate the Cisco iOS. As a security feature, the Cisco iOS software separate management access into the following two command modes. Number one, exit mode, and number two is privileged. So this mode has limited capabilities but is useful for basic operations. It allows only a limited number of basic monitoring commands but does not allow the execution of any commands that might change the configuration of the devices. The user exec mode is identified by the CLI prompt that ends with the greater than symbol, right? So number two is privileged exec mode. This mode is to execute configuration commands. A network administrator must access privilege mode and higher configuration mode like global configuration mode can only be reached from this mode. So this can be identified by the prompt ending with the hashtag symbol. Now, configuration mode and sub-configuration modes. To configure the device, the user must enter global configuration mode, which is commonly called global config mode. From global config mode, CLI configuration changes are mode that affect the operation of the device as a whole, right? And global configuration mode is identified by a prompt that ends with config hashtag after the device name, such as mentioned in this example. And global configuration mode is accessed before other specific configuration modes from global config mode, and the user can enter different subconfiguration modes, right? Each of these modes allows the configuration of a particular part or function of the iOS devices. Two common sub-configuration modes include line configuration mode and interface configuration mode. So when the CLI is used, the mode is identified by the command line prompt that is unique to that mode, right? So by default, every prompt begins with the device name. The reminder of the prompt indicates the mode. For example, the default prompt of line configuration mode is switched config line mentioned in this example, and the default prompt for interface configuration mode is switch config if. So we will discuss these all modes practically in Packet Tracer in our live sessions. Now navigate between iOS modes. Basically, various commands are used to move in and out of command prompt. To move from user exec mode to privilege exec mode, use the enable command, right? So use the disable privilege exec mode command to return the user exec mode. We will discuss this later. And to move in and out of global configuration mode, we can use the configure terminal privileged exec mode command. To return to the privileged exec mode, enter the exit global config mode command. So there are many different sub configuration modes. For example, to enter line configuration mode, you can use the line command followed by the management line type and number you wish to access, and use the exit command to exit a sub configuration mode and return to global configuration mode. And to move from any sub configuration mode of the global configuration mode to the mode one step above uh, in the mode, every time we enter the exit command, right? So now to move from any sub configuration mode to the privileged mode, enter the command and command, or enter the key combination like control plus z, right? And you can also move directly from one sub configuration mode to another. Notice how after selecting an interface, the command prompt changes from one to another, right? Now our third objective is the command structure. So this topic covers the basic structure of commands for the Cisco iOS, and a network administrator must know the basic iOS command structure to be able to use the CLI for device configuration. So a Cisco iOS device supports many commands. Each iOS command has a specific format, a specific syntax, and can only be executed in the appropriate mode, right? Right. So the general syntax for a command, as shown in figure, is the command followed by any appropriate keyword and agreements. So after entering each complete command, include any keyword and argument, press the enter key to submit the command to the command interpreter. Now iOS command syntax check. So basically a command might require one or more argument. To determine the keywords and agreements required for a command, refer to the command syntax. So the syntax provides the pattern or format that must be used when entering a command, right? So as identified in this table, boldface text indicate the commands and keywords that are entered as shown, and uh, italic text indicates an argument for which the user provides the value. For instance, the syntax for using the description command and description string, the argument is a string value provided by the user, right? So the description command is typically used to identify the purpose of an interface. For example, entering the command, the description connects to the main headquarter of a switch to describes where the other device is at the end of the connection. So, so if a command is a complex with multiple arguments, you may use it. The command will typically be followed with a detailed description of the command and each argument. And the Cisco iOS command reference is the ultimate source of information for a particular iOS commands. Now, iOS help feature. The iOS has two forms of help available: context sensitive help and command sensitive check, right? So context sensitive help enables you to quickly find answers to some questions like which commands are available in each command mode, and which commands start with specific characteristics of the group of characters, and which arguments and keywords are available to particular commands, right? So to access context sensitive help, simply enter a question mark at the CLI, and command syntax checks verify that a valid command was entered by the user. And when a command is entered, the command line interpreter evaluate the command from left to right, right? So if the interpreter understands the command, the requested action is to execute it, and the CLI returns to the appropriate prompt. However, if the interpreter cannot understand the like command being entered, so it will be provide feedback describing what is wrong with the command. Now hotkeys and shortcuts. The iOS CLI provides hotkeys and shortcuts that make configuring, monitoring, and troubleshooting easier. So commands and keywords can be short to the minimum number of characters that identify a unique selection. For example, the configure command can be short to conf, right? Because configure is the only command that begins with conf. So an even shorter version just con will not work because more than one command begins with con. So keywords can also be short like tab and backspace, control D and others, right? So while the delete key typically deletes the character to the right of the prompt, and the iOS command structure does not recognize the delete key. So when a command output produce more text than can be displayed in the terminal window, the iOS will display a more prompt, right? more. So the following table describe the short key stores that can be used when this prompt is displayed, like enter key, space bar, and any other key. And this table lists commands used to exit out of an operator, like control C, like control Z, control plus shift plus 6, and others. So now our fourth objective is basic devices configuration. So you have learned a great ideal about the Cisco IOS, navigating the iOS and the command structure. Now you are ready to configure devices. So the first configure command on any device should be to give it a unique device name or host name. By default, all devices by default all devices are assigned a factory default name. For example, a Cisco iOS switch is switch, switch. It is a name, right? So the problem is, if all switches in a network were left with their default names, it would be difficult to identify a specific device. For instance, how would you know that you are connected to the right device when accessing it remotely using SSH, right? So the host name provides confirmation that you are connected to the correct device. The default name should be changed to something more descriptive. By choosing names wisely, it is easier to remember, document, and identify network devices. So, some important naming guidelines for host is start with a letter and it contain no spaces. It should be end with a letter or digit. It should be use only letters, digits, and dashes, and be less than 64 characters in length, right? So an organization must choose a naming convention that make it easy and uh, identify specific device. So the host names used in the device iOS capabilities and lower cases characters and other. For example, the configure show that three switches. spanning three different floors are interconnected together in a network, right? So the naming convention that was used incorporated the location and the purpose of each device. Network document should explain how these names were choose. So additionally devices can be named accordingly, right? So when the naming convention has been identified, the next step is to use the CLI to apply the names to the devices. As shown in this example, from the privileged mode, access the global configuration mode by entering the config terminal. Okay, so notice the change in the command prompt. So now from global configuration mode, enter the command hostname followed by the name of the switch and press the enter. Notice the change in the command prompt name. So always make sure that documentation is updated each time a device is added or modified. Identify devices. So you identify devices in the documentation by their location, by their purpose, by their address, right? Now, password guidelines. The use of weak or easily guessed password continues to be the biggest security concern or of organization. So network devices including home wireless router should always have password configured to limit administrative access. Cisco iOS can be configured to use the some modes and password to allow different access privilege to a network devices, and all networking devices should limit administrative access by security privilege exists by the remote telnet access with passwords. In addition, all passwords should be encrypted and legal notifications provided, right? So when you choosing a password, use strong password that are not easy guess. And there are some key points to consider when the choosing password. So you must use the password that are more than 8 characters, and you use a combination of upper and lower case numbers, special characters, and uh, numeric sequences, right? So and number 3 is avoid using these some password of all devices, and do not use common words because they are easily guessed, like your name and your phone number and your other personal details, right? So use an internet search to find a password generator. Many will allow you to set the length, character set, and other parameters. So most of the labs in this course use simply passwords such as Cisco, such as class, such as your name, right? So these passwords are considered weak and easily guessable and should be avoided in production and uh, like environments. We only use these password for work, classroom settings, or illustration configuration example, right? So avoid these all. Now configure the passwords. When you initially connect to device, you are in user exec mode. This mode is secured using the console. To secure using user the exec mode access, enter line console configuration mode using the line console 0 global configuration as shown in this figure and in this example. So, so the 0 is used to represent the first, and in most cases, it is only. Okay. So next specify the user exec mode password using the password word, and finally it enable user exec access using the login command. To have administrator access to all iOS commands, including configure a device, you must gain the privilege mode access. It is the most important access method because it provides complete access to the devices. So to secure the privilege mode access, use the enable secret password global config command. As you see in this command, as you can see in this command, in this example, right? So virtual terminal VTY, it lines enable remote access using telnet or SSH to the device, and many Cisco switches support up to 16 VTY lines that are numbered of 0 to 15, because 0 is also included. Okay, so to secure VTY lines, enter the VTY mode using the line VTY 0 space 15 global config command. Then next, specify the VTY password using the password command, right? So lastly, enable VTY access using the login command. Now encrypt the password. The startup config and running config files display most password is plain text. This is security threat because anyone can discover the password if they have access to this file. So to encrypt all plain text password, use the service password encryption as shown in your example in your screen. Global configuration command as shown in the example, right? So the command applies weak encryption to all unencrypted password. This encryption applies only to password in the configuration file, not to password as they are sent over the network, right? So the purpose of this command is to keep unauthorized individuals from the view of the password in the configuration file. So you must use the show running config command to verify that passwords are now encrypted. Now banner messages, although require the password is one way to keep unauthorized personnel out of a network, it is a vital to provide a method of declaring that only authorized personnel should attempt to access the device. To do this, add a banner to the device output, and banner can be an important part of the legal process in the event that someone is breaking into a devices. So some legal systems do not allow the this or even the monitoring of users unless a notification is visible. So to create a banner message of the day on a network device, use the banner MOTD hashtag, then the message of the day, and then global config command. So the hashtag in the command syntax is called the it's called a character basically, uh, and it is entered before and after the message, right? So the determining character can be any character as long as it doesn't occur in the message. For this reason, this symbol means hashtag symbol are often used, right? So after the command is executed, the banner will be displayed on all subsequent attempts to access the devices until the banner is removed. Now our fifth objective is the safe configuration. So you now know that how to perform basic configuration on a switch, including the password, including the banner message. So this topic will show you how to save your configuration. Just there are two system files that store the device configuration. Number one is startup config and number two running config. So this is the saved configuration. We can use the startup config. It contains all the command that will be used by the devices upon startup or reboot. And Flash doesn't lose its contents when the device is powered off. And running config, this is stored in random access memory. It reflects the current configuration, and modifying running configuration affects the operation of a device immediately, right? So the show running configuration privilege exec mode command is used to view the running config as shown in this example, and the command will list the complete configuration currently stored in RAM. So if power to the device is lost, or if the device is restarted, all configuration changes will be lost unless they have been saved. To save changes mode to the running configuration to the startup configuration file, use the copy running config startup and config. This is shown in this example. After the running configuration, if changes made to the running config do not have the desired effect and the running config has not yet been saved, you can restore the device to its previous configuration, remove the changed commands individually, or reload the device using the reload privilege exec mode. So the downside to using the reload command to remove an unsaved running config is the brief amount of the time and device will be offline. So when a reload is initiated, the iOS will detect that the running config has the changes that were not saved to the startup configuration, and a prompt will appear to ask whether to save the changes. To discard the changes, enter you can enter an or simply no, right? Now ports and addresses. uh okay, performed a basic device configuration. The fun is not over yet. If you want your end devices to communicate with each other, you must ensure that each of them has an appropriate IP address and is correctly connected. You will learn about IP addresses and devices, port, and the media used to connect devices in this topic, right? So the use of IP address is the primary means of enabling devices to locate one another and establish end-to-end communication on the internet. So each end devices on a network must be configured with an IP address. For example, it include following: computer, network printer, uh, VoIP phones, security cameras, smartphones, mobile handle devices. So the structure of an IPv address is called dotted decimal notation, and it is represented by the four decimal numbers between 0 and 255. And IPv4 addresses are assigned to individual devices connected to a network. So IP in this course refer to both the IPv4 and IPv6 protocol, and IPv6 is the most recent version of IP and replacing the more common IPv4, right? So with the IPv4 address, a subnet mask is also necessary, and an IPv4 subnet mask is a 32-bit value that differentiates the network portion of the address from the host portion, coupled with IPv4 addresses. And the subnet mask determined to which subnet is the device is a member, right? So the example in the figure displays the IPv4 address 192.168.1.10. So its subnet mask is 255.255.255.255.0. Sorry. Okay. So and default gateway is 192.168.1.1. It's assigned to a host, and the default gateway address is the IP address of the router that the host will use to access remote networks, including the internet, right? So IPv6 address are 128 bits in length and written as the string of hexadecimal value. Every 4 bits is represented by a single hexa digit for a total of 32 hexadecimal values. Groups of 4 hexadecimal digits are separated by a colon, and IPv6 address are not case sensitive and can be written in either lowercase, either uppercase, and you can use both of them. Interface and ports. Network communication depends on end user device interface and networking devices interface and the cables that connect them. So each physical interface has specifications, standards, so that define it, and a cable connecting to the interface must be designed to much and A cable connecting to the interface must be designed to match the physical standards of the interface. And types of network media includes the twisted pair copper and fiber optics cable, coaxial cable, and wireless, as shown in this figure, right? So different type of a network media have different feature and benefit. Not all network media have some same characteristics. Not all media are the same purpose. There are some of the different between various types of media. So distance the media can successfully carry a signal. An environment in which the media is to be installed, amount of the data and the speed at which it must be transmitted, and cost of the media and install. Not only does each link on the internet required a specific network media type, but each link also required a particular network technology. For example, Ethernet is the most common local area network technology used by today, and Ethernet ports are found on user devices, right? So uh, other networking devices that can physically connect to the network using a cable. So Cisco iOS layer 2 switches have physical ports for devices to connect. These ports do not support the layer 3. Uh, use the we must use the layer 2 devices, right? So therefore switches have one or more switch virtual interface. There are virtual interface because there is no physical hardware on the devices associated with it. Now our final objective is configure IP addressing. So much like you need your friend's telephone number to text or call them, right? So end devices is your network need an IP address so that they can communicate with each other and each with other devices to on your network, right? So in this topic you will implement basic connectivity by configuring IP addressing on switches and PCs. So IPv4 address information can be entered into end devices manually or automatically using dynamic host configuration protocol DHCP. And to manually configure an IPv4 address on a Windows host, open the control panel, then go to network sharing center, then change adapter setting and choose the adapter, right? So next is right click and select the properties to display the local area connection properties. You can see in this figure. So the DNS server addresses are the IPv4 and IPv6 addresses of the domain name system DNS servers, which are used to translate IP address to domain names such as www.cisco.com, www.google.com, and others, right? Now, automatic IP address configuration for end devices, and basically end devices typically default to using DHCP for automatic IPv4 addresses. So basically, end devices typically default to using DHCP for automatic IPv4 addresses configuration. And DHCP is a technology that is used in almost every network. The best way to understand why DHCP is so popular is by considering all the extra work that would have to take place without it. So in a network, DHCP enables automatic IPv4 address configuration for every end device that is DHCP enabled, right? So imagine the amount of time it would take if every time you connected to the network, you had to manually enter the IPv4 address and the subnet mask, the default gateway, and the DNS server. Multiply that by every user and every device in an organization and you see the problem. So manual configuration also increases the chance of misconfiguration by duplicating another device's IPv4 address. Now switch virtual interface configuration. To access the switch remotely, an IP address and a subnet mask must be configured on the SVI. To configure a SVI on a switch, use the interface VLAN1 global configuration command. And VLAN1 is not an actual physical interface but a virtual one. So next, assign an IPv4 address using the IP address command and subnet mask interface configuration command. Then we will finally enable the virtual interface using the no shutdown command, right? So after these commands are configured, the switch has all the IP4 elements ready for the communication over the network. What did we learn in this module? All end devices and network devices required an OS. Then we did learn Cisco iOS software separate management access into the following two commands: user exec mode and privilege. Global configuration mode is accessed before other specific configuration modes. From global config mode, the user can enter different sub-configuration modes. And each iOS commands has a specific format or syntax and can only be executed in the appropriate mode. And basic device configuration: hostname, password, encrypt passwords, and banner. There are two system files that store the device configuration: startup config and running config. Then finally, IP addresses enable devices to locate one another and establish end-to-end communication on the internet. Each end device on a network must be configured with an IP address.